Okay, let's talk about the chemical methods of controlling microbial growth. There are 4 principles of effective disinfection that really matter when you're using chemical disinfectants. First is the concentration. You might always think that more is better, but that is not actually true. With certain disinfectants, especially things like certain alcohols, the concentration matters and they actually stop working if they get too concentrated. They need a certain amount of dilution in order for the molecules to react properly. So the correct concentration really matters. The amount of organic matter in what you're cleaning up also matters. Some cleaners work really well at cleaning up organic matter and some really don't. Also, the pH. If you have a lot of those hydrogen ions, really acidic things or really basic things with the hydroxide ions, that makes a big difference. And those ions interfere and affect the way chemicals interact and react with each other and with the microbes you're trying to clean up. So you have to be careful with the pH. There's also the factor of time. Some chemicals need to be left on for the right amount of time in order for them to penetrate through layers of contamination and be able to kill off something. And if you don't leave them on there for the right amount of time, then the bacteria survive and they will live to potentially cause serious problems or serious infections, especially in a healthcare setting. So time is critical. So let's look at an application of this. Let's say you're cleaning up a patient exam room. If you wanted to disinfect a surface contaminated by vomit and a surface contaminated by a sneeze, why would your choice of disinfection make a difference? So let's refer back to those 4 principles. So the concentration of disinfectant, as long as you have whatever you're using at the right concentration, that should be fine. The second one was organic matter. Is there a difference in the organic matter in vomit and a sneeze? Yes, there's a huge difference. If you're talking about cleaning up vomit, then it's going to be a much thicker layer of organic matter, and you need the right type of cleaner that can deal with that and can still clean up the bacteria and microbes and really get that surface clean, even with all the other organic matter around it. If it's a sneeze, you're talking about little droplets of saliva and mucus, not a big layer of organic matter. So you would use different cleaners for these 2 things. The third factor was pH. Do vomit and sneeze have different pHs? Yes, absolutely. In the vomit, you're going to be dealing with stomach acid, which is going to have a much lower pH. Remember, lower is more acidic. So you would need a cleaner that can coat and doesn't get destroyed by the acid. If it's a surface contaminated by a sneeze, you don't need to worry about that at all. The fourth one is time. You would have to leave your disinfectant on for a longer time for the surface contaminated by vomit because you'd have a thicker layer of stuff there for it to penetrate. So really the critical ones there are the organic matter and the pH, but making sure the chemical you're using is at the right concentration and left on for the right amount of time will complete the job. So let's look at some other general tips. Each of these groups of chemicals have different properties and act in different ways. No 2 chemical disinfectants are exactly the same. It's important that you read the label of the exact one that you're using so you know what it's effective against. Is it for bacteria? Is it for only certain types of bacteria or certain viruses? And the right concentration to use. Always use proper personal protection. A lot of these chemicals can be irritating to our own airways or to our skin, so make sure if you need a respirator or a little gas mask, if you need to protect your mouth or your nose, or if you need goggles or if you need gloves, then use them. And then finally, no single disinfectant is appropriate for all circumstances because they each have the right concentration and properties. I'm going to repeat that one. No single disinfectant is appropriate for all circumstances. So you have to pay attention to what you're using and how you're using it in order for it to actually be effective, or else you could put somebody's life at risk if you're using the wrong thing and it's not killing off the microbes that are there. So let's look at some different types. One group of chemicals is called the phenols. These all have rings of carbon. Some of these are synthetic, so these represent rings of carbon, and these are the bonds between them. Some of them are naturally occurring. If you look down here, oranges have a phenol called limonene or limonene. Oregano also has another one. So these are naturally antimicrobial types of compounds, and these work by disrupting the lipids, the little fat molecules that are in plasma membranes, and cause them to break open and leak out the cytoplasm. Another group is called the halogens. These would be things like iodine. Iodine tincture means it's a solution in alcohol. You can also have iodine that's in water. And iodine works by impairing or slowing down and blocking protein synthesis. It also messes with cell membranes. Chlorine. So if you look down here, chlorine, water, hydrogen ions, chloride, this is bleach. This is the formula for some reactions with bleach. Bleach is a halogen. It has chlorine in it. It's also interfering with proteins by getting in the way of enzyme reactions in the metabolism. Another group of chemicals is called the surface active agents. These are things that break up the surface tension of things like liquids, waters, oils, and they break up oily films. Soap is a surface active agent. We use soap to wash our hands because it breaks up the oily film from the oils on our skin and allows those bacteria to come off. And this is a form of sanitation, so it's not targeted towards specific things usually. Some soaps have additives that make them a disinfectant, but most basic hand soap or dish soap is going to be sanitation. It's taking the overall microbial levels down lower to where they're safe for regular contact. There is a type of surface active agent that comes up quite a bit in the healthcare setting. They're called quats. It stands for quaternary ammonium compounds. And these work by, again, denaturing proteins, messing with the plasma membrane, and they are very active against microbes. They kill off bacteria, fungi, some viruses, some protozoans, so they're really good at messing things. This is what a quat looks like. So this is an ammonium ion. It has a nitrogen with a positive charge and 4 hydrogens. A quat takes that, or a quaternary ammonium compound, takes that nitrogen ion in the center, and instead of having 4 hydrogens, it has 4 other groups. So you've got carbons, hydrogens, long chains of carbons and hydrogens. Here's a carbon with a carbon ring, and then it pairs that positive charge with a chloride ion. So this is called benzalkonium chloride. The brand name is Zephyran. So if you see a cleaner, it would say the brand would be Zephyran on it. So that's a pretty common cleaner that's used sometimes. This is showing different ways that they clean, and this shows you the importance of that time depending on the cleaner that you're using. So this is an iodine tincture here, iodine and 70% ethanol, and over here we have the percentage of bacteria surviving. So you start at 100%, all the bacteria are there, you put this cleaner on. After 20 seconds, you're down to 60%. After about 90 seconds, you're down to less than 10% of the bacteria surviving, and that would be considered as much as that cleaner can do. These quaternary compounds, Zephyran is the brand name for that. If it's dissolved in alcohol, it needs less time. If it's dissolved in water, then it works much more slowly. And plain soap and water, you can see, is killing off a lot less. And takes longer. So 120 seconds, that's 2 minutes of washing with soap and water. And it has brought the overall level of bacteria down a little bit, but not completely. So you see how that concentration, the way it's mixed, and the time really makes a difference with the different kinds of cleaners. Another really common group is the alcohols. These work by denaturing the proteins, but they do not affect endospores, and they don't affect most viruses. So these are good against bacteria and against some fungi, but not really against viruses, and they don't have any effect on endospores at all. The most common are ethanol and isopropanol. They have to have water in the solution. These are some examples. 70% isopropyl, that is your rubbing alcohol that you can just get at a drugstore. Hand sanitizer has alcohol in it. Clorox you might associate with bleach, but they also make a combination. If you notice this, it says quat alcohol. So this is a combination. It's using the alcohols as well as those quaternary compounds. And a lot of these chemicals, different types of chemicals, can be mixed together in concentrations. But some of these alcohols, if they don't have water, the molecules just will not react and aren't effective. They have to have some of that water in order for the chemical reactions to happen. So most of these, everything that I've talked about as far as the chemicals go, they achieve disinfection and sanitation. Chemical sterilization is extremely difficult, and it's not very common, but it is possible. In order to chemically sterilize something, you would have to use a gas. Ethylene oxide is the one I show down here. That's the one that's usually used. And what it does is it forms a bunch of new chemical bonds with nucleic acids and proteins and just completely destroys them. So when would you use something like this instead of an autoclave? Well, it's really not very common. If you had something that was highly heat sensitive that would get destroyed in an autoclave, then you might want to look at chemical sterilization. But again, it's not that common, but it is possible when needed.